Okay, so yesterday we talked about radicals and simplifying radicals and wishing we could spend more time on it, which we will go more in depth. This ties into being able to use what's called the quadratic formula. Now, the quadratic formula is given to you on the star chart, so it's not something you have to memorize, but you do have to know how to use it. Now, with any formula, you have to know what each variable represents. When I refer to the a value, I'm talking about the number in front of x squared. When I'm referring to the b value, I'm talking about the number in front of x. And when I'm referring to c, I'm talking about the number by itself, the constant. So what you got to make sure, though, is that your equation is already set equal to 0 like before. And what you look at are your variables. A, in this case, is an invisible 1, so 1 is your coefficient. B is the number in front of x, so that's 10. And C is negative 2, not just 2, but negative 2. Now we're going to fill in the quadratic formula. Now how you interpret this is, yes, it technically says negative b, but really you have to remember it doesn't mean that that's always going to be negative. It means the opposite of b. So if b is positive 10, the opposite of positive 10 is negative 10. Then I'm going to continue my formula, plus minus, and again, it's like copying everything down, but instead of the letters, I'm putting in the numbers for its representative. So b squared here is 10 squared, minus 4 times a, which is 1, times c, which is negative 2, over 2 times a, and 2 times 1 is just 2. Okay, now this is the part that involves the calculator. You are just going to type whatever's underneath this radical. So 10 squared minus 4 times 1 times negative 2, and you get 108. Now, I've seen some questions where that's as far as they want you to simplify. But like we practiced yesterday, how can I take this piece further? So I'm going to build a little factor tree over here. What goes into 108? Well, 2. It goes into it 54 times. 2 is a prime. 2 goes into 54 27 times. 27, 3 and 9 go into it. 3 is a prime, and then 3 and 3. You take your factor tree as far as you can, and now I'm going to look for my pairs. My pair is a pair of 2's and a pair of 3's. So here's how we write it. Negative 10 plus minus, and just simplified this. So I have a pair of 2's and a pair of 3's. I bring out one of each. 2 times 3 is 6, with the remainder of 3, over 2. So then I've seen where they want you to stop here, but we're going to take it one more step further, and we're going to simplify it. Think of this like two different fractions. What is negative 10 over 2? Negative 5. What is 6 over 2? Positive 3, with the remainder of 3. And this is as far as we're going to take it. Now, tomorrow we'll talk about how I can possibly go further on some of these, but this is as far as I can simplify this one. Let's talk about number 2. So notice it's not equal to 0. So first I have to add 4x. So I have 8x squared plus 4x minus 5 equals 0, just like we did before on the other part of chapter 8. A is positive 8, B is 4, and C is negative 5. So then I look at my formula. The opposite of B, so the opposite of positive 4 is negative 4, plus minus B squared, which is 4 squared, minus 4 times A, which is 8, times C, which is negative 5, over 2 times A, which is 16. Now this is the part where I grab my calculator and I type it in, 4 squared minus 4 times 8 times negative 5, and I get 176. Now again, just depending on how your answers look, they could either ask me to stop here or simplify this. So I build my factor tree. 2 goes into 176 88 times. 88 is 8 and 11, where 11 is prime, and 8 is 4 and 2. Oops. And 4 goes into 2 and 2. Okay, so I have 2 pairs of 2. So that's 2 times 2, which is 4. Negative 4 plus minus 4, with a remainder of 11, over 2. And again, I could ask you to stop here, but we're going to take it one step further. Negative 4 over 2 is negative 2, plus minus 4 over 2, which is 2, with the remainder of 11. Somebody did ask, do I need to simplify 11 over 2? No. You only simplify the 4 in front of the radical. The 11 is just your remainder, so leave it like that. And this is your final answer, okay? And then you just repeat those steps. So it's a little outside of our comfort zone. It's just getting used to it. A lot of steps at first, but you get the hang of it. Here it's already equal to 0, so A is negative 1, B is 6, C is 10. The opposite of b is negative 6 plus minus b squared, which is 6 squared, minus 4 times negative 1 times 10. The only issue I've seen is if you're not careful about typing this part in, the 6 squared minus 4 times negative 1 times 10. If you don't watch your signs, you're going to mess up everything. 2 times negative 1 is negative 2 for the denominator. So I've got negative 6 plus minus 76 over negative 2. Now 76 is my factor tree. 2 goes into 76, 38 times. 2 goes into 38 19 times. 19 is also prime, so that's as far as I can take my factor tree. So it's negative 6 plus minus a pair of 2's with the remainder of 19 over negative 2. And I'm going to take this one step further. Negative 6 over negative 2 is positive 3, plus minus negative 1 with the remainder of 19, because 2 divided by negative 2 is negative 1. And that's my answer. Again, this is a long note, so please wait until the very end. I know it's a little tedious to watch the same thing over and over again, but we're about to see some different kinds of questions. So make sure you bear with me. For instance, number 4. A is negative 1, B is 7, C is negative 3. The opposite of 7 is negative 7, plus minus 7 squared, which is minus 4 times negative 1 times negative 3, over 2 times negative 1, which is negative 2. I type this part in my calculator, and I get 37. So if I've tried to factor out 37, there's nothing that when I try multiple combinations, there's nothing that would result in an even number without having a decimal. So this is what's considered prime, which means this is technically as far as I can take it, and you'll either see it written like this, or they'll take it one step further and break it up into two fractions. Negative 7 over negative 2 is positive 7 over 2, plus minus, and since this doesn't simplify beyond this, I just leave it as the square root of 37 over negative 2. That's the odd one that we struggled with in class, okay? So just careful there. Let's keep going. This one I need to get equal to 0, so I'm going to subtract 7 and add x squared. So it's technically x squared plus 2x minus 7. Okay, A is 1, B is 2, C is negative 7. So the opposite of B is negative 2, plus minus B squared, which is 2 squared, minus 4 times 1 times negative 7 over 2 times 1, which is 2. I type that part in the calculator, and I get 32. 32, I check my factor tree. I have 2 and 16. 16 is 2 and 8. 8 is 4 and 2. And 4 is 2 and 2. So I have 2 pairs of 2, which is a remainder of, 4, 2 times 2, with a remainder of 2 over 2. A lot of 2's here. When I break it up into two fractions, negative 2 over 2 is negative 1, plus minus 4 over 2, which is 2, with a remainder of 2, and that's as far as I can take it, okay? If I look at number 6, negative 2, 5, and 4, since it's already set equal to 0. The opposite of B is negative 5, plus minus the square root of 5 squared minus 4 times negative 2 times 4 over 2 times negative 2, which is negative 4. And I get 57. Negative 5 plus minus the square root of 57, negative 4. So 57 looks prime at first, but here's the 3 trick is when I add 7 plus 5, that equals 12, and 12 is divisible by 3. I know it's divisible by 3, and 3 goes into 57 19 times. But notice I have no pairs, so I can't, even though 57 isn't prime, I can't factor it out a pair, so that means I can't take 57 even any further, so I technically stop right here. But again, they may ask me to split it up into two fractions. Negative 5 over negative 4 is positive 5/4 plus minus. And again, I just put 57 over negative 4 for the second fraction. Weirdest one, but you might see it. I'm going to talk about number 8 and 9, okay? And for time's sake, just for that. If I look at number 8, I first have to add 4. Okay, so A is 5, B is 9, C is positive 4. The opposite of 9 is negative 9, plus minus the square root of 9 squared minus 4 times 5 times 4 over 2 times 5, which is 10. And whenever I type that in my calculator, oops, minus 4 times 5 is 1 over 10. Okay, this one's an odd one because the square root of 1. When I build a factor tree, what goes into 1? Well, 1 times 1 does. Well, 1 times 1 is a pair. So this is what's called a perfect square, which means it has a pair of 1s, negative 9 plus minus 1, and it doesn't have a remainder over 10. Now, this is the one that we will take even further, but I'm just going to show you today like how to just go as far as you can. Negative 9 over 10 plus minus 1 over 10. And again, tomorrow we'll see how we can go further with this, okay? This one, I'm going to subtract 5, so it's 2x squared minus 3x minus 20, 2, negative 3, and negative 20. The opposite of b here is positive 3 this time, plus minus. Here's where I have to be careful because b is negative. I need to put the negative 3 squared in parentheses underneath the radical. Minus 4 times 2 times negative 20. Over 2 times 2, which is 4. Again, when I type this in, don't just put negative 3 squared. Make sure you put negative 3 in parentheses, then square it. Minus 4 times 2 times negative 20. And you get 169. Okay, now 169 is an odd one because it's not one that has a small number in it. It's whenever I try like dividing it out and I try to, that was not even right. I try to look for factors that go into 169. It's not until I get to 13 that I get 13. Well, 13 times 13 is a pair, which means if I have no remainder, it's called a perfect square. And since it's a perfect square, I don't have a remainder, and I put it over 4. Now here is where I'm going to take it one step further. 3 over 4 plus minus 13 over 4. And again, tomorrow we're going to talk about taking this even further for these kinds. These other ones are as far as we can take it, but these are the most complicated. So bear with me when it comes to that.